Okay, here we have question 12, and it is asking, an object is launched from xo equals 0, yo equals 100, with a velocity of vox equals 50 meters per second, and voy equals 15 meters per second in the presence of an acceleration of negative 10 meters per second. So let's start with A. And A says, find the initial vector velocity and the angle it makes with the positive x-axis. So when we graph them, we get y, the y is 25, the x is 25, and here's a resultant with the angle right here and the right angle over here. So if we do the arctangle of this angle to find theta, we do tan -1 on our calculators equals 25 over 25, and that gives us 45 degrees. And then B equals 25 squared plus 25 squared, so we get equals 35.4 meters per second. Now for B, it's asking us to write the equations for xt and yt. So xt equals x plus vox. This is our initial, and this is our velocity. Since the x only goes either left or right, we are not worried about gravity in this instant. So that is our formula. And then for yt, it equals y initial plus velocity of y plus the gravity formula, because this one does go up or down, times acceleration times time squared, and this is our gravity. So for C, it is asking us to write an equation for Vx and Vxt. So our Vx equals Vox 25 meters per second, and our Vy equals Voy plus AT. For D, it is asking us to find the time to hit the floor and find the range. So we want to know, x equals m over here, and we want to know it in seconds. So we use the equation y times t, y initial plus velocity of y time plus our gravity. So that gives us, by plugging in numbers, 200 plus 25 meters per second squared times time minus 5 plus 2. And we got this from our -10 acceleration. So we can rewrite it as -5 t squared plus 25t plus 200 equals 0. And we can plug this into our quadratic equation, because this would be our A, this would be our C, and this would be our B, and this would be our C. So in doing that, we get our -b plus or minus 4 -5 times 200 over -10. And by doing that, we get these 2 points, negative 4.3, comma 9.3 seconds. But since seconds are only positive, we go with this one. Now, our question E is asking us to write an equation for the trajectory of the object. Oh, do we have to talk about the range? Yes. So for which one am I on? For D, we actually also have to find the range. So to find the range, we use this equation times time. And we do 25 meters per second times 9.3 seconds that we just got from over here. And that gives us 232.5 meters. And that is our range in meters. So for E, we have to write an equation for the trajectory of the object. So trajectory, and we do y of x. But since we only have y of t right now, which is this one, which we just used recently, we do equals 100 plus 25 meters per second times time, and we get time equals x minus 100 over 25, or x over 25 minus 4. And we just plug this back in. Negative 5, x over 25. Oops. Minus 4 squared plus 25 x over 20. And then we get negative 1 over 125 x squared plus 13 over 5 plus 200 plus 20. And then we plug this back into the quadratic formula. So this is our b plus or minus square root of our b again, squared minus 4, then our a times 20, which is our c, over 2 times our a, and we get 2 points. Comma 3, 3, 5. And then if we graph this, we get a parabola with negative 7.5 over here, and then 33.25 over here, and it looks a little something like that. For F, it is asking us, at what time does the object reach its maximum capacity? So we know that the max height, by definition, equals 0. So then we would use this formula. And then all we have to do now is solve for t. We divide by 10. What we do on one side, we do to the other. And then t would equal, give me 1 second. And then we do the max So then by solving for t, we get 2.5 seconds, and that's what it takes to reach max height. But they want it in meters, so to do that, we use this formula, equals y naught plus velocity of y times time with the gravity formula, and then we plug in what we just got right here. Y 2.5, because that's the timer it takes, equals 200 plus 25 times 2.5 t 1/2 plus 1/2, oops, right here, -10, because that's our acceleration, 2.5 squared, and then our y 22.5 equals 231.25 meters. So that's how long it takes for us to reach max height in meters.